Well, most of the stuff was just... I know. It's okay. Hi, Katrina. Oh, it's kind of like it. All right. Hello. Okay. All right. So, function, transformation of functions.
Number 11 on the study guide.
Yep. Transformation of functions. Okay? Or function transformation. This is fairly straightforward. You're going to, bless you. You're going to have what? Horizontal shift, vertical shift, horizontal stretch, vertical stretch. This is going to be something like what I've given you in the past, where it's like, I give you, because there's a lot of ways I can test you on this, but I'm just going to test you on the most simple one, where I give you different functions and you're going to have to tell me, oh, you're going to have to match them up, right? So here's my original function, and then I do a horizontal shift of 2 or something like this, right? And you're going to have to match that with the function, right? So if I say I've got x squared as my original function, then I have x minus 2 squared. What is that? What kind of shift is that?
That's horizontal.
What was that?
Horizontal.
To, yes? To what direction?
Right.
To the right. Right? X minus 2 squared is to the right 2, right? What about if I have x squared minus 2?
Down 2.
Down 2, right? What about if I have 2x squared?
To stretch.
Which type?
Like
This way. I don't know.
It's tough to say, but it's vertical stretch times 2.
Yeah.
Because it gets like
If it was 2x, if it was 2 inside of the parentheses, what kind of stretch is that?
Horizontal.
That's a horizontal. If it actually gets narrower. Yes, ma'am.
So it's safe to say that like when we have those parentheses, those are, like that's when it's like a horizontal, and then if it's like out, it's a up or down, and if it's just like a number in front of the variable, that's when we just say stretch. Like my question is because I remember we had a whole thing about like stretching and compression. Like we're just calling the whole thing a stretch, correct? Or no?
Yeah, but this is going to be much more about practically understanding what's happening, right? So, for instance, I would give you like, it's actually much more appropriate to give you something like x squared plus, or I would give you something like this, right? And you'd have to be able to say, well, that's going to stretch it out like this, right?
So both the fourth and fifth answer both be stretched.
yeah, that isn't.
The difficulty that we have with this specific one is that they're both kind of the same thing. If you can imagine this, right? If I take this function, right, and I stretch it vertically like this, that's going to look exactly the same as if I compress it horizontally.
Right.
Does that make sense? So it's very similar, okay? The time that you end up with something different is if I were to give you x squared plus 2x plus 3, right? Well, a vertical stretch of this would be multiplying everything by 2, right? A horizontal stretch would be like this: x plus 2, or 2x squared plus 2 times 2x plus 3.
Oh, so we have to differentiate between the horizontal stretch and the vertical stretch. How do we I know the shifts, but I thought a stretch was just a stretch. I didn't know there was a vertical stretch and a horizontal. I don't understand the horizontal.
It's like this. A vertical stretch is c times f of x, where everything gets multiplied by some constant.
Okay.
That's a vertical stretch. A horizontal stretch is where you have f of c of x. Okay? So you just plug in some constant. Like here, I plugged in 2x instead of x into my variable. You see? If my original function was x squared plus 2x plus 3, this is a vertical stretch because I'm multiplying everything by 2. This is a horizontal stretch because I'm plugging in 2x into x. You see that?
And then, like, how would you know that? Because like it's not like you're giving us x squared plus 2x plus 3. Unless you're doing that in the parentheses, that we can tell that it's a vertical stretch.
On this exact specific example, you don't really have to think too much about that. It's just you're gonna have graphs and you're gonna have to be able to match them. You don't have to think, is this a vertical stretch or horizontal stretch?
You're more about the shifts.
What was that?
It's more about the shifts?
Well, there are going to be shifts and then there will be stretches. So the thing is, here is like this. The only thing that you could run into is if, for instance, I give you 2x minus 2 squared, or if I give you 2 times x minus 2 squared, let's say.
So that would
Right.
be a horizontal shift and a vertical
So this
stretch?
would be a horizontal shift and a vertical stretch,
Okay.
right?
Mm-hmm.
Now, if instead I give you 2x squared plus 2, right?
A vertical shift and a horizontal stretch?
Yeah.
So when it's something, or there's parentheses and something squared, that's where it's the horizontal shift. But
Mhm.
if it's already like 1/2 x or like 3x, that's a vertical shift.
Vertical stretch.
Stretch.
Well,
Yeah.
1/2 x would be a horizontal stretch. You're
So
making it wider.
the key, listen, here's the key. Here's the key
Fine,
to
I'm
understanding this. A horizontal stretch stretches the distance between the graph and the y-axis. So if I was over here already, and then I applied a horizontal stretch, everything would move away from the y-axis. It's like you're pulling everything away from the y-axis.
Right, but then
Can a
how
stretch just be called a stretch?
2x squared, how would that be a stretch on a horizontal axis if it gets narrow?
I feel like it goes across the x-axis because it's stretching horizontally.
He's not.
You guys know you're using different definitions of
I know, but there's
There's not
different-
different words on it.
But it's determining
Watch,
if it's
just-
going to be vertical or horizontal stretch. 'Cause you know what a stretch is. It's just if it's going horizontally, if it's going vertically.
Watch. If I give you this as my original function, and then I apply a horizontal stretch to it, it's not only will everything get wider, but also the vertex will shift over. And they'll get like this.
Really?
Yes. Because everything stretches away from the axis. And the only thing that's the same is it's going to cross the axis at the same point. But I don't want us to focus too much on this, really, because I'm not going to test you guys too much on this right now. And this is kind of like alpha 2 stuff, but I can print you guys something out that has more better example, more better, yeah, that's a word. So I can print something out, but we only have, let's see, I mean, we don't have much time left anyway, but I can go through the next 2 points in the time that we do have. But look, just the most important thing is just review your old test, review the Thanksgiving packet, and the question that I asked on there, it'll become apparent to you, and I think you'll be able to get the answers to questions. Okay. Composite functions.
I like
Composite functions. Okay. That's the f of g of x thing, right? If I have f of x equals x squared plus 3 and g of x equals 2x minus 1, right? F of g of x is the same as f of g of x. So wherever I see an x, I just plug in g of x. So instead of x squared plus 3, I have 2x minus 1 squared plus 3, right? And then I simplify that, right? If I have g of f of x, that equals, everywhere I see an x here, I just plug in x squared plus 3, right? So that's composite functions. Compound functions class is just like f of x plus g of x, f of x times g of x, f of x divided by g of x, all that kind of stuff, okay? All right, bye, Katrina. Everyone say goodbye.